Well, hello and welcome YouTube to Mr. Robinson's Q&A Power Hour. Sorry, not as much power as normal. This is Integrated Math 1. I will also have a supporting Integrated Math 2 Power Hour video. I'll try and keep them separate, really, for the most part here. Now, what is Mr. Robinson's Q&A Power Hour? Well, every 2 weeks. 2 weeks. Every 2 Fridays. Which this might be uploaded on Saturday, sorry. But every 2 Fridays, my students ask me a series of questions. Well, they do throughout the course of the 2 weeks. They ask me a series of questions, and then on that Friday, when the 2 weeks is up, I will make a video that answers those questions here. And this is what I'm going to do for Integrated Math 1 in our current subject matter regarding systems of equations with word problems. Setting up equations, defining variables, solving answers in context, maybe interpreting some of the terms, little things like that. Integrated Math 2 is working on exponential functions. In a deeper, like exponential properties and simplifying the expressions and radicals. We'll talk about that in that series. But if you want to check that one out, that's what it's going to be on. Now, their questions should be content related. It should be relevant to the last 2 weeks of stuff that we did. And it should not be so specific that it's asking me to just solve a problem for them, because I want to be able to teach something to them, not how to do one problem, but how to do everything of that problem type if they're asking, or whatever kind of question that they have that's based on it. But again, I'd like for their credit's sake, and also when they follow up on questions to get as much credit out of that, I'd love for them to ask within the last 2 weeks content related, current, and relevant questions here. Now, I have a very short set of questions. I think I have like 11 or so questions, so this will not fill up a whole hour, but of course, these videos go as long as they have to. It's kind of like a rule of Fight Club, right? It's a rule of Power Hour. Mr. Robinson's Power Hour, rule number 6, whatever. Questions and answers go on as long as they have to. So we'll go and see how long they take. We'll take a look here. And questions were asked and answered the order that they're received. So they're not necessarily ordered and arranged in topic. I honestly haven't even read the questions yet. I just pasted them in here and I'm getting ready to go. So let's get ready to go. And we are going to start here with the first question, which asks, when are you going to assign us our first quiz/group quiz? See, here's an example of one, and sorry to poo-poo on it right now. I'm going to answer the question, but here's an example of a question that is not content-based. It's not helping you learn the math material better. The quiz is to evaluate you on how much you've learned it, and I know you want to know the answer. And in fact, I was going to say I answered this today, but because this is the first question that was asked, maybe it was asked last week, in which case I didn't give the answer at the time. Again, I'll happily give you the answer. Just as a reminder, this is not content-based. In fact, the last video that I did for them was curriculum-based, so they might assume it's still curriculum-based. I tried to tell them that it's content-based, but that's okay. All right. When are you going to assign us our first quiz or group quiz? So assuming that you are only talking about a quiz, it will be individual. And today is Friday, January 22nd. My next quiz that I'm going to assign to you guys, your first quiz that you're going to get, is Monday, January 25th if you're in third period, or Tuesday, January 26th if you're in fourth or fifth period. It won't be at the beginning of class. We'll, of course, be covering some other stuff first, but it'll probably be toward the tail end of class there. It won't be super long. I just want to get a couple points out there because I want to be able to grade it and give it right back to you guys. But I want to start jumping into systems of inequalities. Not word problems, but just systems of inequalities, just graphing them, making sure that you know how to graph them. So it'll be then. Now, if you're asking about group quiz as in group exam, because you're not going to get a group quiz, but group exam, the kind where you guys share the same grade kind of thing, that is looking to be about 2 weeks from now. I think the week of, I'm looking at this calendar here, the week of February 1st to 5th, expect your group exam to occur then, and the individual exam to then follow. That's what we're targeting right now. As a department, that's what we're targeting. Okay. Next question. In the future, will we need to write an equation with exponents? I was about to say it's not content-based, but I wonder if you're asking about systems of equations. If you're asking about systems of equations, we will not be doing exponents. We are only going to be doing linear systems of equations and systems of inequalities, not exponents. I guess down the line, IM2, IM3. If you're talking about future as an IM1 future, not for systems of equations. You will not be doing exponents. Next unit, however, here in IM1, we will be graphing exponential functions. Now, when you say exponents, you might be assuming we're talking about an x squared function. That's called a quadratic function, and you actually don't hit those until first semester IM2, so next semester. Exponential functions, which seems a little more complex all depending on what you're doing with them, which we're not doing a massive amount of things. But exponential functions are actually raised to the x power. That means your variable is in the exponent, where you plug in numbers in the exponent. Those graphs take off like that, different kind of thing. We're doing those next unit. Now, when you said, will we need to write an equation with exponents, I don't know if you mean, do you need to create it out of what's given, as in a word problem? I got to look deep into that to tell you for sure. I can't say no off the top of my head. What I can tell you is there are a lot of times when you deal with things that are not linear equations that you don't have to create the model. They'll give you the model and you have to respond to things in context on it, of course. But I'm holding back because I don't know for sure. You might be writing an equation because we might be looking at something like, like percentage increase or decrease. And in which case, yeah, writing an equation will be there. They're not so hard to do because it's very clear where you're supposed to put something when it comes to that. So when it comes to word problems, no, maybe, yes. I can't guarantee one way or the other. But that wouldn't be this unit. It's not going to be a system of equations if we do it. It would be a single equation. It would be pinpointed exactly what you put in and where. I wouldn't fret too much about that. Now, will you be dealing with exponents in general? Yes, next unit. Exponential functions in geometric sequences. I'm excited. We'll see if you guys are too. All right, next question asks, in the homework from this week, this sounds current and content related and relevant. Let's hope. What is the difference between this equation, x plus y equals number, and this one, number x plus number y equals number? So what they're asking here is, in this current relevant topic stuff that we're dealing right now, we started by building equations out of slope-intercept form, y equals mx plus b. And then we transitioned into doing things in standard form. So when they're saying in homework from this week, which could have also been last week, we've been working out of standard form, and we've mostly been seeing, and this is to the fault of the book publishers, the people who make the book, the content creators, to the fault of them, they've been creating the majority of their equations where one of them has been some sort of x plus y equals something, and then coefficient like ax plus by equals c, or as they said, number x plus number y equals number. And not being diversifying enough there. And, just understand that there are some where you'll see ax plus by equals c and dx plus ey equals f. You'll be seeing them in both scenarios every so often, just they haven't been building them too much. But your question holds a lot of relevance into what's the difference even between ax plus by equals c, dx plus ey equals f, and this one. And the answer is, when you have x plus y equals blank, your x and y are your defined variables, and they are targeting a specific unit of measurement. And they are identical. They have to match the unit of measurement. I mean, something could be number of pairs of shoes, something could be number of pairs of socks, and total is number of pairs of items. But you can't be number of pairs of shoes plus number of dollars that you have and equal something that you want. So they have to kind of match up item-wise in what you're doing. And that is the equation that's going to express the total amount of what you're defining and what you're looking for in its raw form. We've seen things such as like someone selling a certain number of tickets and how many total tickets do they sell, but you still don't know how many adult and children tickets, or matinee and premium. I don't really know all the different things. Or the x plus y could be, I can't think of examples off the top of my head here, number of miles driven from one person and from another person, and how many total miles they've traveled. So that's the raw form based on whatever you're searching for in the problem. We know the collective total amount, but we don't know them individually. The other equation is a modifier of that equation. Because it's multiplying by something, it's often also changing the unit. Let's take the pairs of shoes and socks, for example. If x is the number of pairs of shoes that we don't know how many were bought, and y is the pair of sold, and y is the pair of socks we don't know how many were sold. We know that in the x plus y equals number, that's how many of total both shoes and socks were sold. The other equation often would involve something with dollar amounts. How many dollars per pair of shoes? How many dollars per pair of socks? When you multiply by those items there, you have changed this to how much money you've made selling pairs of shoes and how much you've made selling pairs of socks. So you've arranged, you've modified your unit of measurement here, and it's describing something completely different. So if I were to write something down to kind of support that there, let's do the shoes and socks thing that I just mentioned here. Let's say that X is number of shoes sold, Y is number of socks sold, and each pair of shoes, I should say, costs $40 per. $40 per shoes. I'll just put shoes to not get too big. And then socks is like, I don't know, $8 per pair of socks. Per socks. So we have an equation that says, X plus Y equals, we sold 30 pairs of shoes and socks. And then we have one that says, 40X plus 8Y equals, I don't know, 500. This one is itemized as far as your number of items. This is a raw equation based on X representing number of items, pairs of shoes, Y is number of items, pairs of socks, 30 is number of total items. But 40X plus 8Y equals 500, this is not items anymore. We've taken $40 per pair of shoes and multiplied by the number of pairs of shoes. That equals how much money you've made from all X pairs of shoes sold. $8 per pair of socks, I don't know if that's expensive or not. I got to think about socks. Times Y pairs of socks equals how much money was made from selling pairs of socks. And now we're adding dollar amounts to equal $500 there. So the difference is the X plus Y equals blank is once again your raw form of whatever you defined your variables as. They have to agree so that you can add them collectively. And then the other ones, obviously, they have to agree as well, but you will have modified what you're referring to now. It will often be a different unit of measurement because of the number of that you're doing times the per pair, dollar amounts or something. And it doesn't have to be that. It could be miles traveled and number of miles per hour. And now you figure out hours traveled and number of miles per hour. And now you figure out how many miles you traveled. It all depends. You know what kind of problem we haven't seen so far yet, though? Is something where it's like, Bobby bought 2 apples from the store and 3 bananas and spent $20. And then Kimmy went to the store and bought 10 apples and 1 banana and spent $32. What is the cost of each apple and what is the cost of each banana? We haven't seen ones like that before. And not that it makes it harder or easier, but this goes away from your kind of question where it says, we've seen that X plus Y equals blank and whatever. Not because these are A and B, but in that they both represent the same kind of thing. They both have to do with dollars. A might mean the number of apples, but 2 times A is because this person bought 2 apples. So 2 apples, A is the cost of each apple, I should say. 2 apples times the cost of each apple is still a dollar amount there, right? So this is dollars plus dollars equals dollars. The bottom equation is dollars plus dollars equals dollars. And they're both dollar equations, but what's different from them? One is a Bobby equation, one is a Kimmy equation. And that's really all the difference is. But they're differentiated to help you recognize once you have 2 bits of information, you could actually break down what the cost of each is. So again, but there is no one that says A plus B equals, which we could have, 1 apple plus 1 banana equals, this could be George who went in and did this. 1 apple plus 1 banana equals, $3. So we don't know for sure what they are. I can't guarantee these are good answers. I don't think they are. But, that's how those things could break down all depending on what you're doing. But these are still dollar amounts here. These weren't number of. So anyway, long answer. I understand that sometimes I can get a little overbearing on them, but I hope that does answer your question. All right, moving on forward. Let's take a look at the next question. And the next question asks, why do we always use X and Y when solving an equation? Not true. You probably said, why can't? So why can't we use any other letters like R or H? So it's not true. We have been using things other than just X or Y. Now, sometimes the book defines for us. Sometimes it makes more sense to use them because, well, let me tell you why you would want to use them sometimes. How should I say this? So, okay, if it's a word problem, I would allow you to freely exercise whichever variables. You can use any variable that you would like to define anything. The question is, can you make sense of what your variable is? And can you not confuse it for something else? So here are instances. Let's go back to the drawing board here. Let's think about instances where you might, so you said R and H, right? What if we're talking about rocks and, what's something that's like rocks? I can't do this. Radios and, okay, roses. I don't know. I'm not going to use your R and H. Let's use apples and bananas. I just did that. All right, apples and bananas. You might use A as the number of apples, or A as cost of each apple, or whatever it is, right? And B as the number of bananas. No one's stopping you from defining them this way. I was about to write apples again. And this is a perfect case where you might want to use this as well. Make sure that you don't just write let A equals apples and B equal bananas, though, because you got to be specific. Is it number of? Is it cost per? Or whatever else you're going to do. Is it the volume, total volume? So there's nothing wrong with doing that. I have not stopped you from doing that. In fact, I've encouraged it every so often to do it. There are times that I discourage it, though. And here are the times. Let's say you weren't doing number of apples, or let's say you weren't doing apples and bananas. What if it was apples and apricots? Those both start with A. You don't want to use, A twice. And you don't want to confuse one of your A's with, they're both AP, in fact. Apricots, I don't know how to spell it specifically. I think it's APRI, whatever, but maybe P is number of apricots. Apricots, I'll pretend like that's how you spell it. I don't know for sure. That can still be a problem because you might forget which one is for which. Apple also has P's in it. In fact, it has more P's than apricots, right? So that can be a little confusing if they both start with the same thing. So that's the time you might not want to use it. When else might you not want to use it? When you're using a letter that starts, for a word that starts with that letter, and that word starts with the letter L or T or Z or S or O. What's the problem with these letters? Unless you're writing them in a specific way, you might confuse them for something that we use otherwise in math, like a 1, a plus, a 2, a 5, and a 0. And there might be other ones that I'm confusing. That being said, if you're doing decently at this, you find other ways to go around these. In L, and look, you could capitalize them. Sometimes we don't. But in L, lowercase could be cursive. A T could be curved. A Z could have the strike through it. S and O are kind of harder to deal with. S, make sure you totally lowercase it and make sure any 5s you put are, I don't want to say capitalized, but they're higher. They have the edges, right? Compare those. And O's is really one I do try and avoid. But O's, you really got to make sure that that's shrunk as well. So when you're writing an equation with S and O, 5S plus 3O equals 19. I'm not loving it. Not loving it. So I would prefer to avoid things that start with S and O for sure, but these other ones can be avoided based on what you do here. Most often you don't see them capitalized, and when you capitalize a Z like this, it can be confused for a 2. Try and make your 2 also like this if you can. So that's another time that you'd want to avoid using those letters there. And a third time that you'd want to avoid using these letters is, maybe you are graphing it, in which case our graphs, X and Y, are very specific to us and how we go about dealing with it, because we know something for an X-axis and Y-axis. We talk about Y equals MX plus B. We talk about X and Y intercept. Those are a lot of times that, I don't want an A intercept and a B intercept and not know which one is which looking from a nutshell, unless you label your graphs, which you should. Unless you label your graphs and have that context clearly defined, sometimes graphing them makes a lot more sense in the ordered pairs and stuff to just use X and Y when you can. So it doesn't hurt to use X and Y, provided you define your variables. It doesn't hurt to use X and Y, graphing them in that case. In fact, I think I remember listing that as a con about solving by graphing, is that unless you're using X and Y in word problems, it can get a little iffy as far as what it is that you're referring to. So that being said, you're going to be doing a lot of graphs down the line, guys. You're going to be doing a lot of graphs down the line where T is your X because it's in reference to time, and you'll be using function notation. So you might be using something like T right here for the X-axis, and then V of T for velocity given a certain time, function notation. That'll happen a lot. I mean, calculus, physics, whatever, in advanced math. So get used to the fact that sometimes you will be seeing different things. But, I don't know, when graphing otherwise and you get to create your own variables, X and Y can be used then. So you said, why do we always use X and Y? We don't. If you see a lot of my homework things, I don't always use them. But I do try and avoid using O for sure. And if if the 2 words started with the same letter, also a problem. All right, next question. If we get a bad grade on a test, sounds curriculum-based, will we be able to come back to a good grade throughout the semester? In general, I like to say yes, but questions, of course, come into play. Number 1, what is a bad grade on a test to you? Number 2, what is a good grade in the class to you throughout the semester? If you get a 0 on the first test and you want to get an A, that's hard to come by. I can't guarantee that you can do that. Now, keep in mind, you are eligible for retakes provided that you cover certain items, checkbox items, including not cheating on a quiz or test leading up to it. But you can also do a retake. You can't get a 0 and then retake to 100. You can retake up to half the score, which is 50. I don't want to get deep into the curriculum, but the point is, if you do poorly on a test to start with, you could also possibly retake and get a better grade. Now, I think we're going to do 4 units, all equal weight here. So, if you get a 50 on your first test, it's reasonable. Okay, it happens. If you get a 50 on your first test, yeah, you can climb through that. Now, that is arguably stating that you'll get pretty high grades the rest of the way. Theoretically speaking, you could get 100s on all those other tests. So what's the average of, 50 plus 100 plus 100 plus 100? Great, I'm asking myself a math question. That's 350 divided by 4, which is 80... about 88%, 87-88%. You're getting a high B+. That's just for test averages. You're forgetting group tests, in which I think that raises the floor for people. I think it should get us higher grades than other people lower grades. So you're forgetting group tests, which are half the weight of individual tests. You're forgetting quizzes. And we're forgetting, of course, the whole homework category and participation and webcams and things like that. That's in the 20%. But all of that goes through the idea of if you get a 50 on your first test and even your retake scores of 50, yeah, you can still even get an A in the class. I mean, other test scores do have to be high. Don't get me wrong. You can't just get C's and B's and expect to get an A in the class. That's not how it works. But if you do badly on test, you have enough unit tests to make up for it. We have the group exams and individual, quizzes and stuff like that can really build stuff throughout the unit if you need to. And remember, your individual test score will match the other ones, so that's good that you can raise those ones up. And the homework stuff. Guys, if you do the homework, if you turn on your webcam, if you participate in class, often the test scores come with it. And I know that wasn't your question, but... Oh, and test corrections as well. Test corrections are not credit recovery, but they're part of the homework. But learning the material will often get you to do well on the test. So I know your if is a hypothetical. I'm not saying that you are going to fall in that camp or not. I don't know who it is who asked this question. But kind of keep those things in mind that those are, for now, all intents and purposes, hypotheticals. We haven't done a single quiz yet. So if you kill these tests in a good way, if you kill these tests, it's not even a question that needs to matter. But if you do badly on a test, depends on how bad that grade is. If you get a 0, I don't know if you can get an A. I don't think you can. Don't get a 0. Don't get a super low grade, all right? Someone who gets that low of a grade, listen, you're not deserving of an A. An A is not only about excellence, but it's about consistency and excellence, right? A is excellence. I want you guys to keep that in mind. Not everyone always gets an A on everything. All right. The sum of two numbers is 33, and the sum... Okay, so see, this is an example of a specific kind of question. I don't credit these very highly, but here we go. The sum of two numbers is 33, and the sum of 7 times the first number and 5 times the second number is 197. I don't see the question, but I assume the question is, what are the two numbers? So, okay, let's go ahead and answer this question. This is one where, when students follow up on these kinds of things, not much for me to speak on, but let X represent the first number and Y represent the second number. Oh, see, now I'm going into someone saying, why do you always use X and Y? Because I don't want to use S for second number. And I don't want to use 2 because that's not a variable. So let X equal the first number. And let's let Y equal the second number here. All right, what did you say? The sum of two numbers is 33. So I add X and Y, and I get 33. And the sum of 7 times the first number, and 5 times the second number is 197. Now, I used plus because they said sum. If they said difference, it's subtraction. So keep that in mind as well. These are kinds of problems that are really easy to build because they tell you outright what to do, provided that you know what the word sum means, or difference, depending on the problem. As far as solving it goes, that's kind of, that takes a little bit. So I would probably use the elimination method here. I cannot shrink this equation down any further because I can't divide 7 by 5 or 5 by 7. But I could multiply this top equation here by, say, -5 all around. I think this actually was a homework question. Listen, if this was a homework question, this is another reason why I don't like answering these questions. I have a solution guide video for this question, and I'm probably answering it the same way. So I would say next time, if I know that this is a homework question, I'd say I'm not going to answer it because I already did answer it once. But okay, here we go. Multiply everything by -5. -5x minus 5y is -165. And when I combine like terms, I eliminate my y's. 5y minus 5y equals 0. 7x minus 5x is 2x. And 2x equals 197 minus 65 is 32. Therefore, x equals 16. So we know that the first number is 16. The second number, I can use the top equation, say, substitute 16 for x and solve for y. This is a homework question. I remember the other one's 17. Subtract 16 from both sides, y equals 17. So our answer is the first, I'm going to say it out loud, I'm not going to write it. I've spent enough time doing a problem that I've already done on a video. The first number is 16 and the second number is 17. Thanks for the question. You don't get credit for anything. I'm sorry. I hope I helped you, though. I hope I helped you. That's why I answered it. All right, here we go. I'm not being rude. You're being rude. All right, the next question here is, what does in the context of the situation mean in systems of equations word problems? This is a good question because test questions ask, what does x represent in the context of the situation? What does 21y represent in the context of the situation? In the context of the situation, so context means how does it relate to what you're talking about? So, if you walk into a conversation with me and I say something like, yeah, she'd totally do that, you're like, okay, I need context here. What is it that she'd do? Would she jump off a building? Would she go rob a bank? Would she answer that question correctly? Right? You need context. You need to know how it relates to what it is that's being talked about. So when we say in the context of the situation, when you see this circumstance right here from the last problem that I did, this context did not have to be about just some first number, some second number. This context could have, of course, been number of pairs of shoes plus number of pairs of socks equals 33 total pairs. There's context involved there. And $7 per pair of shoes, cheap pair of shoes, plus $5 per pair of socks, all this times number of pairs of socks equals $197. There's context involved with it now. Now we know it's about number of items with pairs of shoes and pairs of socks. Now we know the dollar amounts that are involved, and we can represent these terms within the context of the situation. What does x represent? The number of pairs of shoes. What does 7x represent? If 7 was the number of the cost per pair of shoes in dollars, then 7 times x represents the total amount of money spent or collected, made on those pairs of shoes. If there were 10 pairs of shoes, it's $70. See, there's context because there are units of measurement. So in the context of the situation, what it often means is there's some sort of unit of measurement that you'd be referring to. And it also means that you need to understand the situation at hand to decipher those units and to interpret ones like that 7x. That's a little harder to talk about, but you got to understand that 7 has its own unit of measurement. That's dollars per pair of shoes. X has its own unit of measurement. That's number of pairs of shoes. When you multiply the number of dollars per pair of shoes by the number of pairs of shoes, that equals total amount of dollars. So in the context of the situation means interpret and tell them what are the units of measurement that's being, that's taking place there, really. Can you tell them the unit of measurement, I think, is really the best way to say it. And also, in a word problem, they're all about sentences. We should be writing things as sentences as well. We should, reciprocate. We should give back. So hopefully that answers your question there. And it's a good question because that's something that will clearly be asked on a test. Not many questions left, though, for us here. 4 more questions. The next question asks, when solving real-world problems, how would you solve a problem time-related when your answer is a negative? That's a good question. I'll tell you what. In the majority of questions that we do, and when you're tested as well, you will not be seeing negative answers. That doesn't mean they don't hold any form of context. Okay, now you're saying how would you solve a problem time-related? You solve it the way you would solve it mathematically, substitution, elimination, whatever. If you're asking how would you interpret that, you specifically said time, so I'll answer it as time. Normally, guys, time problems have a model that occur as a result of us starting the time then and there, and that's how our thing behaves the way it does. Let's say that you are doing something with a, sorry, one second. Let's say that you are babysitting, you're babysitting, and you charge somebody a constant, starting amount just for driving and going there, like $5 just for arriving, and then $10 per hour on top of it. Then you have an equation y equals 10x plus 5, like that, or whatever variables we use. Okay, what if we solve and we get x equals -2? Our time is -2 hours worked. The context doesn't really work and apply there because we didn't start working until time 0. When x equals 0 is when this model even made sense. So the reason that I stated the reason why we won't get negative answers and things is because normally the model doesn't actually work for them to begin with. Because our model only applies when we start working. We start the clock, hour 0 begins, now we're making the money. Before that, we weren't making that money because we weren't working. So oftentimes, when we have problems like that involving time, it wouldn't occur that way. Now, there are times when it does occur. There are times when it can make sense. And I'm thinking about, if you guys remember that worksheet where we had the Florida population increasing. I don't remember the numbers, so I'm not going to assume anything like that. But they said x equals the number of years since 2010. So when x equals 0, that means year 2010. So what if they said something like, if this was a system of equations, that wasn't a system of equations question, but what if there are two different population models where x is the number of years since, let's say, 2010, and let's say they say, in what year were these two populations the same? And it might not be, and listen, if you get x equals 5, that answer is the populations will be the same in 2015. If we get x equals -2, that still works because years occurred before 2010. We can subtract 2 years and we're in year 2008. When were the populations the same? They were in the year 2008. Now, the x equals -2, that negative answer, did hold context in our situation. Now, when we were tracking our model, maybe the model really started, maybe we started our model in 2010, but if we extrapolated, which means if we assumed things outside of the model because time occurred before then, for the sake of this model, you can still use that. So that's a good question. We could get an answer like that. I'm not going to play with ones with you on that, but it's very possible that you can have something like that if your model can work before that and if time made sense to occur before that. So I hope that makes sense. And look, x can also represent year 0 AD, year 2 BC, 2 years before that still occurred. So time, when the model still functions in that kind of way, can still work, all depending. That babysitting example, it doesn't work because that's when you started babysitting, at hour 0. Babysitting didn't happen before that. But population grew and stuff before that, and the model can apply. Anyway, I'm off that problem. Thank you for that question, though. That was a good one. All right. When you move to decimal, I'm going to stop for 1 second. This doesn't have to do with the question. This has to do with me. I noticed when watching back, and I don't watch my videos back in full, but when trying to find timestamps for things, I notice when I read a question, I start scratching myself a lot. It's not intentional. I don't know what it is. It's just it's a fidgety thing. I don't know what it is. And I just noticed I scratch myself. I'm like, I'm not going to do that. Okay, hands down. Here we go. Next question asks, when you move the decimal, does it have to go to the right? I really want to scratch myself. You know why I scratch myself too? I'm processing. I'm like that. So, okay, does it have to go to the right? Well, no. This is because I have a scratch right now. No, it doesn't have to go to the right. Do we often move it to the right? So, listen, if you are dealing with a decimal, you would want to move it to the right because the whole point of decimal movement is to get rid of the decimal. Now, remember, guys, every number features a decimal. The number 1 also means 1.0000. You know what I mean? So, number 1, it still is a decimal after the 1, but regarding your making them integers, when I say get rid of the decimal, I say turn your things from non-integer values into integer values. So we've seen things with dollars, right? $2.50 is 2.50. $1.35 is 1.35, and it's multiplied by x, whatever. We want all these decimal shifts. So shift the decimals 2 places to the right, which is allowed because mathematically what you're doing is you're multiplying everything by 100. So we most often see decimal shifts to the right. Now, we wouldn't often call the other thing decimal shifts to the left, but you're asking, when you move the decimal, does it have to go to the right? No, we can go to the left, and I've done it only a couple times with you guys. I wouldn't call it a decimal shift to you guys. We say it in another way, because decimal movement, of course, is a math operation, and we can do other math operations in instances like this. When might I move the decimal to the left? It's when I have integers with trailing zeros. Let's say I have 20x plus 30y equals 100. What I could do, remember when I said that every number still has a decimal? Technically, this is 20.0, whatever, it's 20 point. This is 30 point, and this is 100 point. Those zeros, to me, are insignificant in the way, this one zero per value is insignificant to me in a way that if I decimal shift all these 1 unit to the left, 1 unit to the left, 1 decimal place. I can't do this 2 to the left. I have to do them all 1 to the left, whatever. Now I have an equation that says 2x plus 3y equals 10. Now, am I allowed to do that? Yes. Do we call that a decimal shift often? No. You know what we often say? We say, let's divide everything by 10. Now, dividing by 10 is a decimal shift to the left. Therefore, a decimal shift to the right is multiplying by 10. So when we've seen dollar amounts, guys, we get 2.50x plus 1.35y equals 7.45, whatever it is. We talk about 2 decimal shifts places to the right here. We are multiplying by 100, but as long as you understand that you're moving the same amount for each thing, I'm fine with you then writing it as 250x plus 135y equals 745. And the cool thing about this is, if we're talking about money, and this is in dollars, then at least this one is in cents, 250 cents. 135 cents, 745 cents. So there's still relevant context when it comes to money there. What I would often do though now here is I'd try divide everything by 5 to make numbers smaller. So do you have to go to the right? No. Do we often go to the right? With decimals, we would want to go to the right. I don't see me wanting to go to the left with a decimal. I don't see you wanting to do it either. When would we go to the left? If we have some trailing zeros where we can do that, but we often don't say move it to the left. We often just say divide by 10, divide by 100, things like that. But it is a decimal shift to the left when we do that. Okay, so I hope that answered the question that you had there in kind of greater detail with supporting examples. All right, next question is, will division and multiplication be prevalent this year? I saw this question once because the student asked me somewhere else and I said submit it in the form, but it's not a great question in the sense that we're always multiplying and dividing. Will it be prevalent? Look around. We're looking at things all around where we divide. I just literally in this thing just divided everything by 10. And 2x means 2 times x. I don't know if this is a question to try and receive some form of free credit that's going to be applied. You're not getting much out of this thing here. Yes, it'll be prevalent anywhere you go in math. Anywhere you go in math. I don't really know what else to say to that. In all the future math things that we do, expect multiplication and division. Yes. Starting from 3rd grade, expect division and multiplication to be prevalent. Sorry, that's all I can say to that. All right, and the last question here for IM1 is, when will our test be? So I kind of answered it in the beginning one. That wasn't the beginning question, and remember, this is not content related. I am aiming for February 4th for 3rd period and February 5th for 4th and 5th period. That is 2 weeks from today. February 5th is 2 Fridays from today. That's the aim. Now, Super Bowl, I'm not doing it in relation to the Super Bowl. The Super Bowl is that weekend after February 5th, so I wouldn't want to try and do it right after that because people might be out of town when it comes to Super Bowl stuff, or they might just be watching the Super Bowl. So I don't want to try and do it immediately right then, so I want to try and shoot for it before if I'm able to. That would be nice. And then I can grade it during that time. I can watch the Super Bowl and grade exams. That's fine. So that's when your test will be. I hope that answered that. All right, so that'll do it for me, this guy right here, guys. This was Integrated Math 1 Q&A Power Hour. You can find, if you watch this video in full, you can go back and find a single question number 1 to, I think, 11, in the description section below with timestamps here. And I hope that this was good for you. It certainly was good for me. Take care, guys.